Hi, welcome to Unit 7, Day 1, Part 2. This is preview to solving stoichiometry problems. So in Part 1, we learned what stoichiometry is. It's using mole ratios to convert from the amount of one thing are given to the amount of something different, what we're asked to find. So what I want us to do in today is sort of go over some example problems so you get a sense of the type of problems that you'll be dealing with in this unit. And then we're going to start practicing identifying or choosing the correct conversion factors to solve. So here are some example problems that would be classified as stoichiometry problems. First one, how many hydrogen atoms are in 2.5 moles of water? Second, how many moles of water can be made from 4.18 moles of H2 according to the reaction shown, which is H2 2H2 plus 1 O2 goes to form 2H2O. And how many grams of O2 are needed to make 24 grams of water according to that same reaction? So these are all examples of stoichiometry problems because you're starting off with one thing and you're trying to convert it into something different. And you have to use mole ratios to do it. Now you'll notice that with these problems, the amounts of the given and the find, some of them are in moles, some of them are in mass, some of them in a number of atoms and molecules. They could also be in volumes, etc. So the amounts that you're starting off with or trying to find can vary. So with that being said, one thing that you'll see in these problems is that they actually look kind of similar to the mole conversion problems that we did before. And in fact, they pretty much follow the same two main steps. The first step being to choose the correct conversion factor, and then the second step is using dimensional analysis to solve. Now, in terms of using the dimensional analysis to solve, that really just requires a lot of practice until you feel super confident with it, but it's actually not that difficult. Usually the more difficult part is choosing the correct conversion factor to solve. And if you don't do that, then you won't be able to do the rest. So we're actually going to focus on step 1 for the rest of this video. Just choosing the correct conversion factor. And then later on, you'll see how to actually solve these problems. So let's take a look at this problem again. How many hydrogen atoms are in 2.5 moles of water? So the first step with all these problems, of course, is to choose their correct conversion factor. And we do that by reading the problem, identifying our given and find. So in this case, we are given 2.5 moles of water, and we're trying to find number of hydrogen atoms. And then using that to map out a plan. So we're going from moles of water to number of hydrogen atoms. Now you may be thinking, oh, okay, so I should just probably get a simple conversion factor to go from moles of water to number of hydrogen atoms. But it's not quite that simple. The thing is that water and hydrogen atoms, they're different substances. And you cannot convert between different substances unless they're both in moles. So in this case, we're going from moles of water to number of hydrogen atoms. They're not both in moles yet. So what we have to do is make sure that they're both in moles in order to convert between these two different substances. So our first step is to convert between moles of water and moles of hydrogen. Once we have the moles of hydrogen, then we can get the number of hydrogen atoms. So the conversion factors that we would use, starting off with going from moles of water to moles of hydrogen, would be using the mole ratio. You use mole ratios when you're trying to convert between different substances. And in this case, since this is involving a molecule, not a chemical reaction, we would use the subscript. So remember that in the case of a water molecule, in one water molecule contains 2 moles of hydrogen because of that subscript 2 by the hydrogen. So that's our first conversion. Just convert from moles of water to moles of hydrogen in order for us to change from different substances. Now, once we've done that, we can do that last conversion, which is to go from moles of hydrogen to number of hydrogen atoms. And for that, we would actually use the mole map. That's actually a simple mole map problem because we're going from moles of a substance to a different amount of that same substance. We're not changing things here. We're still dealing with hydrogen atoms. And so in that case, the part of the mole map we'll be dealing with is the Avogadro's number part. 1 mole is equal to 6.02 times 10 to the 23. So in this example, we'll see that we actually need to use a mole map because our find in this case was not in moles. And if your find or given are not in moles, you actually need to use a mole map to convert it to moles. Because remember, the only way you can convert between two different substances in a stoichiometry problem is to use is to make sure that the substances are in both in moles and use your mole ratios to convert. Okay, let's look at this problem. How many moles of water can be made from 4.18 moles of H2 according to the reaction? All right, so we're choosing our conversion factor. Our process is always the same. We're going to read the problem, identify our given and find. We're given 4.18 moles of H2, and we're asked to find moles of water. So in this example, we're going from moles of H2 to moles of water. Now, H2 and H2O are two different substances. Can we convert from moles of H2 to moles of H2O directly if they're different substances? Yeah, we can because they're both in moles. So in this example, the only conversion factor we need is the mole ratio. And the mole ratio for this problem, since it involves a chemical reaction, is the coefficients in the balanced chemical equation. So according to the balanced chemical equation, sorry about that. I had to correct that typo. So anyway, so in this example, the mole ratio is going to come from the coefficients in the balanced chemical equation. Since we're trying to convert from 2 moles, from the moles of H2 to moles of H2O, we use their coefficients. So the conversion factor we get is 2 moles of H2 is equal to 2 moles of H2O. Now, of course, you can always simplify that since the 2 to 2 ratio is the same as a 1 to 1 ratio. So we can reduce it to 1 mole of H2 is equal to 1 mole of H2O. Either conversion factor would work. So it's important to note that in this example, we actually don't need a mole map because both our given and our find are in moles. And if our given and find are in moles, we can go ahead and convert to and from them directly using the mole ratio. Let's look at the last example problem. How many grams of O2 are needed to make 24 grams of water according to the reaction? So once again, we're going to identify our given and find. We're given 24 grams of water, and we're trying to find grams of O2. So we're trying to go from mass of water to mass of O2. Now, can we do that directly? No, they're different substances, and they're both not in moles. In order for us to convert from between different substances, they both must be in moles. So the first thing we have to do actually is convert from mass of H2O to moles of H2O. And then we can convert from moles of H2O to moles of O2 because these would be the same. They're both in moles, even though they're different substances, they're both in moles. So we can use our mole ratio to convert. Once we have our moles of O2, we're not done because we want our answer to be in grams or mass of O2. So then we would convert from moles of O2 to mass of O2. So our conversion factors would look like this. First step is converting from mass of H2O to moles of H2O. Well, we would use the mole map and we would use the molar mass of H2O to do that. Once we have done that, now we can use our mole ratio to go from moles of H2O to moles of O2. And once again, we would go to the balanced chemical equation. So I find my H2O, there's 2 in front of it, and my O2, there's an invisible 1. So the conversion factor will be 2 moles of H2O is equal to 1 mole of O2. Then finally, I would want to go from my moles of O2 to my mass of O2 because I want my final answer in grams of O2. So once again, I would use the mole map and I would use the molar mass of O2 to do that. So in this example, we actually need to use the mole map, but as you can see, you only need to use the mole map for a stoichiometry problem if your given or find is not, are both not, if your given and find are not in moles. So both given and find must be in moles in order for you not to use the mole map. If they're not, you're going to use the mole map. Okay, so which of the following stoichiometry problems would you need to use the mole map to solve? And these are the same problems we saw before. So as you can see here, A and C, we needed the mole map because, again, the given and the find are not in moles. You need both to be in moles in order for you not to use the mole map. Why don't you try that with this CFU? So read these example problems. The given and finds have been highlighted for you. And which of the following do you need to use the mole map for? This is select all that apply. All right, so go ahead and pause the video now. And when you press play again, the answer will be revealed. So the answer to that is both B and C. You would need to use the mole map because if you look at B, for example, B, your find is and your given are both in grams. So in order for you not to need the mole map, both your given and find must be in moles. If they're not in moles, then you need to use the mole map. In this example, your given is in grams, so you're given your amount in mass, so you're going to have to convert that into moles. So you need the mole map for that. All right, lastly, we're going to talk about our sort of comparing stoichiometry versus mole conversion problems. Because if you look at sort of the problems, the process sort of seems the same. The questions kind of seem similar. You're using mole maps. So what's exactly the difference? So let's go over some differences here. So in a mole conversion problem, and an example given at the bottom, how much does 2.5 moles of O2 weigh? You're trying to convert from one amount to another amount of the same substance. So you're not changing substances. Whereas in stoichiometry, you're trying to convert from one substance to a different substance. And again, the example at the bottom of the stoichiometry circle is provided. Now, in a mole conversion problem, your given and find must be the same substance. So if you're only doing a mole map, you're not doing stoichiometry at all, then both of them must be the same substance. But in the stoichiometry, the given and find must be different substances. So they have to be different things. In a mole conversion problem, the given and find must be in different amounts. So you would have to be given one amount in mass and the other amount and your other amount in mole, or it could be mass and volume, for example. But in stoichiometry, it doesn't matter what the amounts are in. They can be in the same amounts, like both can be in moles. Your given and find can both be in moles, or they can be in different amounts, like one in moles, one in mass. In terms of how we get our conversion factors, so in a mole conversion, you use the mole map for the conversion factors. Whereas in stoichiometry, you're going to use mole ratios, whether it's from a coefficients and balance chemical equation or from the subscripts in a chemical formula, you have to use mole ratios. Now, with that being said, in a stoichiometry problem, you may need to use the mole map to convert things into moles or from moles, but the heart of a stoichiometry problem is using those mole ratios. All right, now in terms of what they have in common. So both of these problems are going to involve converting from given to the find. And in both problems, the steps are the same. You're choosing the correct conversion factor and then you're using dimensional analysis to solve. So it's kind of important to know sort of what the differences are. And the reason why I say that is because sometimes people forget for a stoichiometry problem to use the mole ratios, and that's the most important thing. Or sometimes people are trying to use mole ratios for a strictly mole conversion problem. By understanding the difference, you're better able to navigate the problem. So that's why we've presented this here. All right, so what's next for you guys? After today, we're going to start going into practicing step 1 again, just doing a bunch of problems on that, and you'll have an exit ticket on that. All right, that's it for this video. Have a quality day.